In this problem, we're given several quadratic equations. For each quadratic function, we need to calculate the vertex by hand and write it as an ordered pair. And then finally, we're going to determine the axis of symmetry and write it down as a linear equation in the form x equals a number. What I've done is take the first equation here, g of x, copy it down. Now we're supposed to find the vertex, which ends up being the highest or the lowest point on the graph. So since it is a point, it's going to have notation as an xy pair. And it just turns out that the first coordinate of the vertex is always given by this formula negative b over 2a. After finding the x value of the vertex, we can simply plug it in the equation, the original equation, to find its y value. Before I can do negative b over 2a, I first have to identify the values of a and b. A, by definition, is always the coefficient on the x squared term. So here's my x squared term. Its coefficient would be 1/4. The b is defined to be the coefficient on the x term, including the sign. So the coefficient on x is -6. So now I need to plug these two values into the formula negative b over 2a. So b is -6, but I'm to change the sign on b. I'm supposed to do the opposite of b, so that'll be +6, and divide that by 2 times whatever a is. A, as I said before, is the value 1/4. So the x-coordinate of my vertex is going to be found by simplifying this fraction. 2 times 1/4 is 2/4, or a half. So what I need to do is take 6 and divide it by a half. A half goes into 6 12 times. So I find that the x-coordinate of the vertex is 12. If you do this on the graphing calculator, I always tell students to do negative b divided by 2 times a. In fact, when I write the formula negative b over 2a for the calculator, I usually write negative b divided by parentheses 2a. To remind them on the calculator, you need parentheses around the 2 and the a to let the calculator know that the a is in the denominator as well as the 2. So this would have looked like this. You would have done 6 divided by parentheses 2 times a, and our a value is 1/4. So 1 divided by 4. So there's our b, negative b divided by 2a, and it gives us 12. So I know that the x-coordinate of the vertex is 12. To find the y-coordinate of the vertex, we need to plug 12 back into the equation. Now the problem is stated to do things by hand, but usually that means just not to use the intersect feature. So you can plug 12 into this by hand, literally by hand with no calculator at all. 12 squared would look like this. My machine here isn't working as well as I'd like to today. It'd be 12, replacing all the x values for 12, would be 12 squared over 4, minus 6 times x. We're replacing x with 12. I don't know why I keep switching to a selection tool. So 6 times 12. Maybe I'll just start using the mouse. 6 times 12, and then minus 9. So eventually you're probably going to grab a calculator. You know, 12 squared is 144, 144 over 4, etc. So eventually you're probably going to reach for a calculator and do it this way. So I'm going to be placing 12 in for x here. So that's going to be 12. The squared key is right here. Divide by 4. And then subtract 6 times 12, replacing x with 12. So I've got my 12 squared over 4, subtract 6 times 12, don't forget subtract 9. Use the subtract key, not the negative key. And I'm going to get that the y value of the vertex is -45. So on paper, the y coordinate came out to be -45. This machine is not really helping me much today. So this expression came out to be -45. So my vertex has coordinates 12, -45. So what we have here is a parabola that opens up. The a value is positive, so I know I'm going to have a U-shaped curve. It's going to open up. And what we just found is it's the lowest point. The lowest point on the parabola is going to be 12, -45. So at this point, we don't need to actually graph it on the calculator. Maybe stay to the end of the video and I'll graph it for you to show that that's a plausible answer. For now, I'm just going to go back to Math AS and type in what we got. For negative b over 2a, we got 12. When we plugged negative b over 2a into the function, that's what this function notation says, plug it back into the equation, plug 12 into the equation to find out the y value of the vertex. That came out to be -45. As an ordered pair, the notation is left parenthesis, so shift 9 on the keyboard, 12, comma, -45, right parenthesis, shift 0. And then the axis of symmetry is actually the vertical line that cuts through the center of the parabola. So if you have a U-shaped curve like this, you notice that if you were to draw a vertical line right through the vertex there, that the left-hand side of the graph kind of mirrors the image on the right-hand side. Meaning if you could almost fold the right-hand side of the parabola about this line, it would come over here and match the left-hand side. That's called symmetry. So that axis of symmetry, the line that cuts through the middle, since it's vertical, is going to have an equation x equals a number, and it's always whatever the x value of the point is. Our x value is 12. So the axis of symmetry is going to have the equation x equals 12, and you must use the correct variables here. So if you used y equals, or if you forgot to use a letter at all, you'd get it wrong. So x equals 12 is what they're looking for. Just a word of advice here. If there's no value of x, like in the next problem, that means the coefficient front is 0. So in this case, a would be 2, b would be 0. And there's also no constant at the end, so c would be 0 as well. That might help you do the next problem. If you're interested, this is what the graph of this would look like, just to show you a plausibility check on my vertex. I'm going to go to y equals, type in my equation, x squared divided by 4, subtract 6, I'm going to use the x key, subtract 9. Now, I usually tell students to start by hitting zoom 6 just to get the class. I'll have the calculators all in the same window. What that gives you is a window from negative 10 to 10 on the x-axis, negative 10 to 10 on the y-axis. So remember I said that the graph is going to be a U-shaped curve. So what's happening is the graphing calculator is graphing it, but in the window that we chose, you don't see very much. So we're actually seeing just this piece of the parabola right here. So we need to tell the calculator we need to see further to the right and further down to be able to see the whole parabola. To do that, I'm going to hit window. Now my x max lets me go further to the right on the graph. It's currently at 10. My cursor's up here, so I'm going to down arrow. Instead of 10, since I know my vertex happens at x equals 12, I'm going to leave some room and maybe go to, say, 25. And then my y min, let me go down to my y min, is negative 10. That's how low the graph goes. Remember, we need to go down farther. Negative 10 was not enough. In fact, the y value of our vertex was negative 45. So I'm going to go down at least as far as negative 45. In fact, I'm going to go negative 75, be a little bit lower. I'm going to regraph it. So just as a plausibility check, at least the vertex is happening in the correct quadrant, which is quadrant 4. If you plotted 12 comma negative 45, this looks plausible. In fact, I don't recommend doing this to find the vertex, but you can hit trace and just kind of right arrow or the cursor over just as a plausibility check and see that 12 comma negative 45 looks very plausible as being the lowest point on this graph.